Okay, the next lesson we're going to do is 3-4, which is solving equations in this form, ax plus b equals c. Again, it all has to do with linear equations, equations that create a straight line. All right, up until now we've been working on all sorts of things that had to do with linear equations. The first was just to understand the concept of something being linear, and it's going to be either a constant increase or a constant decrease if it's linear. Okay, and that was just the first introductory thing, and also talked about something being collinear, which means that the points are on the same line. Then we had 3-2 that said you can actually use your tables and graphs to solve equations. Okay, and it might seem like, why would I, do all this where I scroll through this table, or I trace on the graph? Well, part of it is just so that you get really good at moving around your graphing calculator. But part of it is that sometimes it's easier to jump right onto a graph that you have right here, okay, and find what this point is by tracing and calculating, then scrolling up and down through a table trying to find what you're looking for. But sometimes it is actually easier just to jump right to a table and find what you're looking for. But the point is to get you fluent so that you can choose those things. When can I use these things to help me solve problems? Okay, then lesson 3-3 we're skipping because it has a CAS, a computer assisted software, and we don't need to worry about that. And then finally we're here at 3-4, which is, as I said, ax plus b equals c. You solve this with 2 steps, and we jokingly call this kill Bill and annihilate Anna. Those are our 2 steps to solve this. Okay, so that's the big idea. We can solve an equation in this form in 2 steps. The homework is to read 3-4, and then there's a couple problems for 3-4 that I left out. So look at that before you do the homework to make sure you see which problems you can miss, or skip rather. The first thing they talk about in 3-4 is this famous mathematician and philosopher whose name is René Descartes. And one of the famous quotes from René Descartes as a philosopher is, "I think, therefore I am." You might have heard this before. One of his probably much less famous things is his contributions as a mathematician, or less famous to the general population. But as a mathematician, because we said math is a language, we all had to agree with how we were going to speak that language. And René Descartes is a person who made a rule about a particular aspect of the language, in that when we use the letters A, B, and C, those actually don't stand for unknowns, things that we're trying to solve for. They're just standing there holding the place for numbers that we actually do know. The ones that are actually the unknowns are X, Y, and Z. Okay? So he was like, you know what, let's use this A, B, and C for numbers that we know. Let's use X, Y, and Z for numbers that we don't know and that we're solving for. And, as I said, he was a mathematician, and actually in the time of the Renaissance, and everybody said, yeah, let's all agree to that same way of setting up equations. So that's where we come up with this form of ax plus b equals c, because a actually stands for a number, and b stands for a number, and c stands for a number. It's just putting it in the form so that we can agree on, oh yeah, what comes first and what comes second, where x is honestly the only thing that we don't know. Okay, so in that form we can solve for x in 2 easy schmeezy steps. The first one is to get rid of the b, and the second one is to get rid of the a. So if we have an equation like this one here, negative 5x plus 18 equals 24. That one actually is already in the form of ax plus b equals c. A is negative 5, b is 18, and c is 24. So if it's already in that form, we can start by solving it by getting rid of b, killing Bill, and then getting rid of a, annihilating Anna. So right here, we're going to get rid of b. b is 18. To get rid of 18, we're going to subtract 18 from both sides, okay? So that would be the subtraction property of equality. Now, depending on what b was, we might want to use the addition property of equality. But you're either going to subtract or add the same thing to both sides, whichever you need to do to get rid of b. So once we do that, we're here. We've gotten rid of b. And now we have negative 5x equals 6. Essentially what you have right there is ax equals c. And the second step is to get rid of a. So we need to get rid of that negative 5. ways you can get rid of the negative 5. You can either multiply both sides by the reciprocal of negative 5, or you can divide each side by negative 5. Okay? So if we want to multiply each side by the reciprocal, that's the multiplicative inverse property. Okay? And the reciprocal of negative 5 is 1 over negative 5. Okay? So we're going to multiply both sides by the reciprocal. And we multiply negative 5x times 1 over negative 5. All right? You are left with negative 5 over negative 5x, which therefore then obviously just becomes x. And 6 times the same number on both sides, the reciprocal of negative 5. 6 times the reciprocal of negative 5 gives me negative 6 over 5. Okay, so the x is negative 6/5. All right. Sometimes, though, that you don't have things already in the form of ax plus b equals c, and you have to get it there. So this is a problem from your book, and it says you got this person who's a zookeeper, and they earn $10.80 per hour as their hourly wage. Every hour they work, they earn $10.80. Now, they get paid back for their meals, and in this particular time period, the person spent $8 on meals, and they get paid back for transportation, and the person spent $3 for transportation. And they combined this all together, the zoo did, and gave this person a check for $83.90. So it said, okay, that included their meals, their hourly work, and their transportation, but how many hours did she work? Okay, so you have $10.80 per hour, plus the $8 for the meals, plus the $3 for the transportation, and the whole check was $83.90. That's not in the form of ax plus b equals c, so we've got to get it there. Well, you look at it and you can say, what can I do? I can combine these two like terms together, the 8 and the 3, and get to here. 10.80h plus 11 equals 83.90. So we combine like terms, and we got to ax plus b equals c, where a is 10.80, and b is 11, and c is 83.90. So we've now can do the steps of solving for h. First thing is to get rid of b, kill Bill. Bill in this particular case, as we said, is 11, so we've got to subtract 11 from both sides. And what we're left with after we do that on the left side is 10.80h, and what we're left with on the right side is 72.90. Okay? So we've now killed Bill. We got rid of b. Now we've got to annihilate Anna. We've got to get rid of the a, and the 10.80, remember, was the a. So that's what we got to get rid of. To get rid of the a, you can either multiply each side by the reciprocal of a, or you can divide each side by a. So you can either do this or that. Either one will get you to the same point. And 1080 over 1080, they cancel out and you have h. 72 over 90 becomes 6.75. So she worked 6.75 hours. Okay, let's try another one where we don't have it in the form of ax plus b equals c yet, and we have to get there. So this looks like a problem you've had in the other lesson, where they give you this one where they say, I have this big rectangle, and one side of it is 4, and the other side has pieces. It has one piece that's 3, and another piece that's n plus 10. And they also tell you the whole rectangle's area is 94 square centimeters. Okay? Now if you remember, area is equal to length times width. Okay? So given that, and all the information they gave us, they want us to solve for n. All right, so we've got to get into ax plus b equals c if we want to solve for the unknown. So right now we have 4, which is the length, or the width rather, times this, which is the length, equals the area. And we look at it and say, well, what can we do first? Well, if you think about PEMDAS, you'd say, I can do something inside the parentheses. I can combine the 3 and the 10 and get 13. So now we've done everything on that, and we're, as far as inside the parentheses, and we have 13 plus n equals 4. Okay, so now if you still think about it in terms of PEMDAS, which is a handy way to approach it, there are no exponents. So we skip that, And then we look for either multiplication or division, whichever comes first. And in this equation right here, there actually is multiplication. It's 4 times 13 plus n equals 94. So we can do the distributive property of multiplication over addition, and multiply 4 times 13 and get 52, and multiply 4 times n and get 4n. Okay? And now we're at 52 plus 4n equals 94. We're almost at 5x plus b equals c, but we're not quite. Okay? We actually have b plus ax equals c. So if we want to be very, very careful, we would commute them around and put the ax plus b equals c, and then get rid of the b and then get rid of the a. So let's do that and get rid of the b by subtracting 52 from both sides, and ended up with 4n on the left and 42 on the right. So we have 4n minus 42, subtracting from both sides. And now we can get rid of a, annihilate Anna. So we have 4n equals 42, and we want to get rid of the a. We can either multiply each side by 1/4 or divide each side by 4. Either case, that will get rid of the a, and we'll end up with n on the left-hand side, and 42 over 4 becomes 10.5. So the n is 10.5, and therefore that side is 3 plus 10.5 plus 10, and the whole side is 23.5. All right, one last thing. As we said, they're not always in pretty little ax plus b equals c form. Sometimes you have to simplify them, but also sometimes you just have to commute them around or write them in the proper way. Because this guy doesn't have any extra numbers in it, but it's just not in the right order. It is in the right order, but it's not plus b is the problem. Okay? This guy is kind of in the wrong order, this guy's in the wrong order, and this guy is actually in the wrong order. It may not appear like that at first, but it is. Okay? The first one is actually ax, okay, minus 53 equals 7. All right? So, to get it into the right way for ax plus b equals c, we have to change the minus 53 to adding a negative 53, which is the same thing. And that means a is 3/2, b is negative 53, and c is 7. And you probably realize that's the thing we want to be careful about. If it says ax minus b equals 7, you want to rewrite it as this so that you end up with this. All right. This one here is similar because it's also minusing 53. So again, we want to change it to adding a negative 53. It's actually written c equals ax plus b, which is pretty darn close to ax plus b equals c. You would just move the ax to the plus b to the left side and move the c to the right side, and you'd be in the right form once you set it up like that. Okay? The third one is actually c, and then b, and then ax, okay? Where a, again, is 3/2. B, this time, you could just think of it as negative 53 right here, okay? And c is 7, okay? Now it actually, like I said, it's like this. So you could rewrite that just by moving the ax and the b, commuting them, and then having ax plus b equals c. Okay? And then the last one is actually written as b plus ax equals c, this here. And you could just move them around again. Okay? So until you're really used to it, it's probably best to get yourself in this form so that you're not accidentally doing something you didn't mean to do. So get it in that form, okay, by either using the definition of subtraction, which is what we did right here, or by using the commutative property. Okay? Just be careful of your negatives. And that's pretty much 3-4.